So we will title this 7.1, Warm Up. And I think you have some space at the top of page 573. For all of these questions, we're going to solve for theta, where theta is between 0 and 2 pi. These first three questions are calculator questions. A, I want you to solve 3 sine theta equals -2. B, I want you to solve 8 tan theta plus 3 equals 0. And C, 4 cos theta minus 16. Actually, no, I'm not going to do that one. Just do those two. These two with calculator. They're the first two. How did you do? Divide by 3, you get your reference angle as 0.73. When you're rounding, it's good practice to start using these approximation signs, as you need to really do that next year in your grade 12 course. And technically, another good thing to practice would be to rounding to 3 significant figures. So I should actually, that would be correct to 3 significant figures. Okay? Then, because sine is negative, that would be in quadrant 3 and quadrant 4. There would be your answers, again, rounded to 3 significant figures. So you would go pi plus your reference angle and 2 pi minus your reference angle. And this warm-up is exactly stuff that we did in chapter 6. 6-point fun. Well, part of it we did when we did the handout, and some of it was like all the way through. Here, get tan by itself, you get tan of theta equals -3/8. Did you get a reference angle of 0.359? And then because tan is negative, it's in quadrant 2 and quadrant 4. Again, those are to 3 significant figures. Here are the next two. Now we have non-calculator ones. For the first one, solving for cos, you get cos theta equals 4, which is bigger than 1. That means not possible. Second one, solving for tan, you get -1/√3, and this is where you might get stuck unless you rationalize it. And when you rationalize it, you realize, oh, that is on my pi plate. What family is that? That is pi over 6 or 30 degrees, but since all of these questions are in radians, we think pi over 6, and we think quadrant 2 and quadrant 4, because tan is negative. No, it'll be a mix, some radians, some degrees. So you have to be able... So you have to, if you're solving and it's in radians, you need to be in radians, degrees. Find out tomorrow. So now, the thing that we're going to look at next is what happens if I don't just say from 0 to 2 pi. What would happen if for part D I said instead of 0 less than or equal to theta less than or equal to 2 pi, I tell you that theta can be anything. So that doesn't mean just from 0 to 2 pi. It doesn't mean just from 0 to 4 pi. It doesn't mean just from -2 pi to 4 pi. It means forever. That's going to be the idea, right? Because these two answers are still going to be two of our answers, right? But then we're going to get every single angle that's coterminal with them will also be answers. because basically what's happening is we figure out that one answer is 5 pi over 6 and the other answer is 11 pi over 6. So another answer would be this one plus 2 pi. Yeah. So we can write it as, and sometimes when you write two different answers, you can put a big squiggle bracket like this. One answer is 5 pi over 6, and then, now, we've always written 2 pi times k. This is the same thing, but generally, for whatever reason, pi is written at the end. So you'll start seeing plus 2k pi instead of 2 pi times k. It means the same thing. If you like putting the k at the end, it's not wrong. But you're going to start seeing me write plus 2k pi. And you would also have 11 pi over 6 plus 2k pi, where k is an integer. Yes. And so this is a right answer, and you're not going to be marked wrong for this. But what Emily said and noticed is she noticed that in between this one to this one and this one to this one is how much? Just pi. So if you started with one of them, 5 pi over 6, and just added k pi, where k is an integer, can you see that that would hit all of those answers as well? So this answer is even more eloquent and elegant because it's just one thing, but both of those answers would be correct. Yes? None of this with the like coterminal angles, that could be on your quiz because it's something we did, but we had that on the first quiz, right? But this is going to be on chapter 7 quizzes. Okay, and we're going to do one chapter 7 quiz after 7.2 that we're going to do before our test. So this will be on that. Okay. So this is called the general solution. So at the top of your next page, you have some space in the top left-hand corner of page 574. And the general solution is when theta can belong to all real numbers. So we're going to write out some steps that are going to help us. And it's basically exactly what we did in that question before. When I changed it to be theta's all the real numbers, what actually happened? Well, first, you solve, I'm going to say like normal, from 0 to 2 pi, or from 0 to 360 degrees, depending if the question is in radians or degrees. But generally, if it doesn't say, it assumes that it's in radians. So step number 1, you're going to just solve it like normal. Find all of your angles from 0 to 2 pi. Step 2, you are going to add 2k pi, where k is an integer. Maybe I'll put that in a green box so that we know what we're adding. To each of those answers that you found from 0 to 2 pi. At the bottom of page 574 is example number 1. You can put an X through it because we're not going to do it, and we're going to do this question instead. So this will be our example number 1. We're going to solve for theta where theta is over all real numbers, for 7 sine theta plus 1 equals 0. So again, what we just wrote before is start just like you normally would, just like we did in the warm-up. How would you solve all the answers from 0 to 2 pi? Well, you would get sine by itself. Move the 1 over, divide by 7. Next thing you'd find, you'd look, is that on our pi plate? No. So we need to get our reference angle. So we go sine inverse of 1 divided by 7. Again, when we find a reference angle, use those approximation signs because we're rounding it. 0.143. And then because sine is negative, we would get one answer in quadrant 3. Ooh, 3 significant figures. You see that in your calculator when you get 2.998. Okay? How would I round this to 3 significant figures? Because that's 4 significant figures right now. It would be 3.00. Feels kind of weird to do that. Oh yeah, I just subtracted it. Oh man, it was such a good number. Oh, how disappointing. Thank you. I'm so disappointed. So quadrant 3. Yeah, what did I do? I found an angle in quadrant 2, but that's not where sine is negative. Sine is negative in quadrant 3. Pi plus our reference angle. It's probably not going to be nearly as exciting a number. No, it's so disappointing. 3.28. So one answer is 3.28. And then in quadrant 4, you would go 2 pi minus your reference angle, 6.14. So those would be our 2 answers between 0 and 2 pi. Then how do we write our general solution? Our general solution, we take each of those answers and add 2k pi, because that would write all of the coterminal angles for them. And I think there's space maybe at the top of page 575, so that's where you can try this one. And if you want to check, I'll put the answer up.